when we talk about environment, there's a lot of variables you need to measure. You need to measure temperature, precipitation, wind speed, wind direction, but also the atmospheric composition, because atmospheric composition impacts weather, impacts climate, impacts state of environment. My name is Oksana Tarasova. I work in World Meteorological Organization. Our organization is dealing with metrology, which includes weather, climate, and we also work with water and environment. And personally, I am dealing with the questions related to atmospheric composition. That is extremely important for metrology, meteorology, and for climate. And when we talk about this agenda and this topic, it's important to understand that when we talk about environment, there's a lot of variables you need to measure. You have, for example, a deposition of some chemicals into the soil or into water. It pollutes the soil, it pollutes the water. But we install the environmental regulations that control the deposition of those pollutants or control the air quality. So when we introduce the environmental regulations on some constituents, for example, Montreal Protocol is dealing with ozone-depleting substances. So we have a regulation on ozone-depleting substances, but it's getting warmer and warmer. The climate is changing, so we do need to use the air conditioning systems. So what do we use to fill them in? So the chemical industry creates new substances. We call them new substances of concern. And oftentimes there is no supporting metrology to perform the measurements of those substances or to understand what are the changes, because the levels currently in the atmosphere are pretty small. So you need to have very good standards to actually make environmental measurement, which would make sense and which you can compare between different countries, between different industries, or between different nations. So metrology is really fundamental in a sense that you always compare the same measurement across the different countries. And it gives you the assurance that, okay, that's not just country A, which is under-reporting, country B, which is over-reporting, but we are all on the same scale and doing the same thing. We also need to ensure the traceability for the new devices. Like in air quality, we traditionally use the gas analyzers, we can use the cylinders, but there are some things where you cannot use a cylinder. So you don't have a reference material. So you need to actually create a reference material for environmental measurements. Like there are developments in metrology which are related to black carbon, which is type of the aerosol. But there is a lot of concerns about microplastic, which is also in the form of particles present in the environment, in the atmosphere, in the water, in the soil. So how would you characterize that one? What is your metrological support to get this measurements quality controlled? The other issue is the measurement techniques themselves. And we, as an environmental scientist, we use the instruments which are available on the market. We'll try to develop new instruments, but probably most of the people who use the techniques, they don't have the labs to develop new kind of instrumentation, which is required based on the new principles, but can be used in the field to make the environmental measurements. But also, how would you assure the quality of these instruments? There is a boom of the low-cost sensors in air quality. And you can't calibrate them the same way you calibrate the gas analyzers. So I think that there is a substantial role of metrology in helping us to do emerging environmental substances in the environment, characterizing new instruments, and getting new idea of the traceability, how it can be applied to environmental measurements.